Vado. Invito ad accomodarvi, buonasera a tutte e tutti e benvenuti a quest'ultima serata del Green Week, Festival della Green Economy da Italy Post, Fondazione Simbola e Corriere della Sera. Inizio subito chiedendo alla regia se possono abbassare un po' le luci perché non si vede nulla da qua su, quindi se si possono abbassare leggermente, grazie. Allora, questa sera torna alla Green Week un ospite che abbiamo conosciuto 5 anni fa, un ospite che vi presento brevemente in italiano, poi come è scritto anche in programma l'evento si svolgerà in inglese. È un ospite che abbiamo invitato appunto 5 anni fa alla Green Week per parlare di un tema che era attuale allora e che è ancora più attuale oggi, appunto del riscaldamento globale dello Ghiacci. Il nostro ospite di questa sera, Peter Wadhams, è uno dei massimi esperti mondiali di FIA. È stato direttore del Scott Polar Research Institute di Cambridge dal 1987 al 1992 e è visiting professor sia all'Università Politecnica delle Marche che al Politecnico di Torino. Ha condotto oltre 50 spedizioni al Polo Nord, è stato tra i primi, se non il primo, ricercatore scienziato a misurare lo scioglimento dei ghiacci e quindi a rilevare lo scioglimento dei ghiacci del Polo Nord negli anni '80. Da quel momento la sua attività scientifica si è sviluppata parallelamente all'attività di sensibilizzazione, di attivismo quasi sul tema del riscaldamento globale e ce ne parlerà questa sera. Della Royal Geographical Society, della Finnish Academy e dell'Arctic Institute of North America. A questo punto non ci rimane che chiamare sul palco Peter Wadhams. Farewell to Ice, Addio ai ghiacci è il titolo di questa serata ed è anche il titolo di un suo libro scritto un paio di anni fa, tra l'altro finalista al premio Galileo per la divulgazione scientifica. Welcome to the Green Week Festival. Welcome back, actually.
Thank you.
We were honored to have you as our guest 5 years ago, and
Yes.
we are honored to have you back tonight. And so I will leave you the floor. I will sit here with you, please.
Okay.
I will leave you the floor, and then we'll discuss what happened in the last 5 years. Is anything gotten better or worse?
Okay, thank you very much, and I'm very pleased to be here. The gap between the last time I was here and now is when a lot of things have happened with global climate, most of them bad, and but the break due to COVID has made it possible to see just how fast global change is happening, how fast the climate is warming, and therefore how much more urgent it is that we do something about it. So the title is Goodbye to Ice, but is it still possible to save the planet? I think that it is, but only if the human race makes an enormous effort. Otherwise, it's not. So how the climate is changing, how it's been speeding up just this year. In fact, this last month, there's been a rapid acceleration of the indicators of warming. And therefore, if we're going to do something to save the world, we have to do it very fast. Okay. Right, here we go. The history of climate change goes back a long way, and we have data going back a long way. This is a 600,000 year data set obtained from ice cores, which is drilling holes in ice sheets to see how the temperature has changed over. And what we know is that the Earth has gone through periods because of small fluctuations in the Earth's orbit. You go through periods where the temperature is warmer than it used to be, it normally is. And then when it's colder, of course, we know these as ice ages and interglacial periods. So what we have in this record here is a record of about 10 ice ages. Usually an ice age lasts about 100,000 years. And the interesting thing about it, it looks like a random record, is that the Earth sinks slowly into an ice age, and then it rises rapidly out of it after a few thousand years. And the two interesting levels are that there is a level that the Earth likes to be at when it's cold, and an Earth level is at when it's warm. This is levels of carbon dioxide content in the atmosphere. So without human beings being around driving cars, we still had, during an ice age, a concentration of about 180 parts per million for carbon dioxide in the air. And then in the warm periods between, we'd have 280. So the Earth would settle between two preferred values for its carbon dioxide content. So we, oh yeah, it works. Okay. And we see we came out age, which started 100,000 years ago. We came out of it about 12,000 years ago. And all the previous ice ages, when we came out of this carbon dioxide content stayed at about 280. But this last time, things went kind of mad. The temperature, the carbon dioxide content continued to go up, and instead of being at 280, it's now at 420. And this has never happened before in the last million years or so. So we've done something to the atmosphere and to the climate that's caused a major upset. You can see that we've more or less doubled the level of carbon dioxide. Now, we know that carbon dioxide is a real indicator of temperature, because I'll show that as carbon dioxide content increases, the temperature of the planet increases. So by giving the planet an extra dose of carbon dioxide in the last few centuries or decades, we've given it also a large dose of heating. And this is what we're suffering from today. And but we didn't know what we were doing. Of course, the human race often doesn't know what it's doing, but we didn't know what we were doing until 1896. And this paper was written by a very famous Swedish scientist, a Nobel Prize winner, called Svante Arrhenius. Now, you won't have heard of him, but you might have heard of his great grandniece, who's Greta Thunberg, one of the very energetic people pushing the world to do something about climate change today. But Arrhenius showed that what was causing the Earth to warm up was the extra amount of carbon dioxide we were putting into the air by burning fossil fuels, burning coal, burning oil, burning gas. And he worked out, because we understood the laws of physics a bit better in his day than we did earlier, well, that's amazing. I got going the wrong direction, in fact. But, I should get the hang of it. Okay, so this indicates how fast things have changed. So the work of Svante Arrhenius showed us what was going on, but the way it worked was that were new laws. Well, they weren't new; they were old laws. But we discovered the laws of gas pressure. That's the Stefan Boltzmann law and the Wien law, and we showed it was possible to see that some gases actually, here they are. Some gases increase the temperature of the planet by preventing the Earth from radiating out heat into space. Normally, the Earth's in of temperature because we have heat coming in from the sun, and the Earth itself warms up and gives out radiation at a different frequency, which goes back into space. And this is fine, so long as there's nothing standing in the way of the radiation getting out into space. But there are, and these are the certain gases in the atmosphere which absorb radiation. They don't let it out into space, and therefore the planet warms up. It is called the greenhouse effect because it really is like a greenhouse. The radiation coming in gets in, but the radiation trying to go out doesn't get out. Oh, yeah. Okay, so the gases that are on this nice little smooth curve, we see what the world should, how the amount of heat should be distributed between different frequencies. But instead of a nice smooth curve, we have these big, and there's a hole. Each hole is marked by the gas that's causing it, as water vapor, methane, nitrous oxide, ozone. But the biggest hole of all is carbon dioxide. This is this great big hole here. And what happens is the more carbon dioxide we have in the atmosphere, the more heat is absorbed within the atmosphere and doesn't get back out into space. So carbon dioxide is the most powerful of the greenhouse gases. It holds back heat, causes the planet to warm up. Now, the more CO2 we have in the atmosphere, the more oil and coal we burn, the deeper that hole gets and the warmer the planet gets. So that's our fate. The trouble is we didn't know about it. We knew that from Arrhenius that what caused the Earth to warm up, but for some reason we didn't bother to find out how much it was warming until 1958. So it took us 60 years from Arrhenius's time to inquire about what's going on with the planet, how much is it warming. So at that stage, the Scripps Institute of Oceanography in America built an observatory on the top of Mauna Loa, which is the tallest volcano in Hawaii, and to avoid contamination. And they've every day since then, the carbon dioxide content, the temperature, and a lot of other parameters of the atmosphere. And this is the known graph that comes out of that, and that's really, we could call it our guilt graph, because it shows that the carbon dioxide in the atmosphere has been rising steadily, and not steadily, but in an accelerating way to get far, so that we're getting warmer faster. We started in 1958, and the CO2 level was really not that much above the days before humans existed, but then it rose faster and faster, and it's reached now 420, and without a stop. You can see it's actually one little period in the middle where it flattened out a bit. That was because there was volcanic eruption, and which put a lot of dust into the atmosphere. But other than that, it's just kept on increasing and increasingly rapidly. So everything that we say we're doing about carbon dioxide and trying to save the world is actually untrue, because you look at this curve and nothing that we've done has had any effect. Okay. And because the temperature follows the carbon dioxide content, the temperature of the planet has gone up in an accelerating way as well. And this shows the last 100 years or so of climate warming for the planet, which has gone up by about 1.5 degrees. Okay. I wanted to show, I'm making an effort to show this beautifully colored graph here because this is my wife has a knitting pattern. It shows the for every month of the year, going down the left-hand side, it ranks that what was the hottest year and what was the coldest year out of the last 40 years. And you nearly always find that the hottest years are the ones on the right-hand side here. That's recent, and the coldest years were the ones 40 years ago. In other words, this shows for every month of the year, the climate has warmed up. We're dealing with hotter months, whether it's spring, summer, autumn, winter. The months now are much hotter than they were 40 years ago. So that change of colour from blue to red really shows us that our whole planet has been warming up. And well, some events have been really happening very recently. So I think we want to have a special look at those. And the first one is that last year, 2021, was the hottest year ever recorded by any instruments. And the hottest day ever recorded was in the middle of 2021. It was at a place called Swaihan, which is in the United Arab Emirates. Well, and the temperature was 51.8 degrees. Now, it's a temperature at which you would die because the amount of your blood will stop. But it's in the middle of the Arabian desert, so the few people who are there have got access, obviously, to air conditioning. But the funny thing that really got people worried was that you had almost the same temperature in a place which never gets warm very much, and that's a town in British Columbia, in the highest part of the coastal mountains of BC, where there's glaciers all around. And there was what's called a atmospheric river of heat came northwards through the coastal mountains and heated up and heated up so much that it caught fire. So this town of Lytton, which I've driven through in the past, no longer exists. There was so much underbrush and trees there that ignited because of the warm temperature that the town burnt to the ground. So that was an extraordinary thing to happen in a place where you don't expect a lot of heat. And if we look at the temperatures in the world, we find that the last 6 years were the hottest 6 years ever recorded. And so here's the kind of sheet of crimes that we've committed. That this extreme heat last year was repeated again this year, only India and Pakistan. And you will have all read about birds dropping dead from the sky and incredible heat. So that is equivalent of last year's heat. And done by man have occurred in the last 30 years. And the warming that's been happening has now risen to 1.1 degree C. In fact, it's 1.5 degrees C, but the scientists kind of fiddled the data so that it didn't look so mad. And we find as every year there's now an increasing number of wildfires, brush fires in the world, where it gets very dry and the underbrush catches fire, where you can have disastrous fires. We had those in Sardinia last year for the first time, and I'm going back to Sardinia this year to have a look at some of the results and what's being done. And the wildfires in California were the biggest area ever for wildfires, 4 million acres. So things are getting worse very rapidly. We notice every year something happens, and sometimes it's very bizarre. Like just this month, there was a sudden outbreak of heat in Antarctica. If you of the Dome Sea, that's the research center or a research area on the top of the Antarctic ice sheet, that's Italy and France. And the temperature on the top of the Antarctic ice sheet is usually about -60 degrees in the winter. So this set of curves here shows typical winter conditions, -60, and -20 in the summer. But here that red peak there was coming down into winter conditions. Suddenly the temperature rose for no known reason by 38 degrees. So the temperature in the middle of the Antarctic ice sheet was 38 degrees warmer than it has ever been before. This river heat coming northwards, which we don't understand where it comes from, where it goes. But that was the most extreme heat we've ever seen in Antarctica. That's what the observations show, but modeling shows some of the same things. One of the best modelers around for the regions is Patty Michelle Schaefer, who works for the US Air Force, and she has a model where she first of all checked whether her predictions agreed with observations, and they do, measured through a year. And so she then took them further to predict the future and found that the blue line here is this steady warming that we get. We've been having for the past many decades. And this year, suddenly the warming took off to a new, faster value, which is about twice as fast as the previous decades. So this is lines. So we're now getting a change to a warming rate about double what we had before. And that is part of the explanation for all these extreme events that have been happening. And predictions also go towards the amount of sea ice present in the Arctic, and the blue line is sea ice present in the winter, the red line is sea ice in the summer, and you can see that the line in the middle there, which is today, shows that there'll be sea ice still for a few decades to come, but not in the summer. In the summer, it looks like it's going to disappear by, well, we think about 2028. So in a very few years, there won't be any sea ice left, and that will cause enormous increases in the speed of warming. So let's look back at what we thought was going to be the case when I was young and when I was studying sea ice back in the 70s. We thought that it would stay the same forever, that in the winter on the right, the sea will be covered with ice, that's the light blue, joining North America and Siberia to form a kind of single mass. And that would retreat some way in the summer months, but not very far. So we thought this was what would happen forever. But unfortunately, because of the warming effect, okay, so the warming effect, the summer retreat, instead of just being a small retreat, became and half of the ice has gone in the summer months. So you can sail through the Arctic now without meeting any ice. And you can see the difference. For instance, this is about 2012, and I was working up in northwest Greenland. That's a place called Karnak. It's the northernmost settlement in the world. It's an Inuit settlement near the very northern tip of Greenland. And we were going out with the Eskimo hunters who hunted polar bears up there. And they would have used these big, heavy wooden sledges to bring bears. So that you can see one in the distance. The problem was the ice is getting thinner all the time, and it was making it more dangerous for them. People go through the ice, and then they'd be drowned. So we outfitted their sledges with little radar sets on the bottom of the sledge to give a warning if the ice got thinner and was a threat. So they've been operating with this radar, care of the European Union, and keeping them from sinking through the ice. But you can still see that the ice is still there. But then last year, this is the same scene. In fact, it's the same sledge, looking across to the same mountains. And instead of the dogs being able to run over and pull the sledge, the dogs had to wade through the water. And so you can see this big change has happened just in a few years in North, which is as far north as you can get. One of the problems with this is that the Arctic is warming faster than anywhere else in the world. It's warming about 3 times as fast as any other latitude. And we see on the right-hand side there, the warming in the Arctic compared to the rest of the planet. We don't really know exactly what causes that. People say that it's the retreat of the sea ice is making the surface of the Earth darker, so it absorbs more heat. But when you look at old records, you find that the Earth was warming in the Arctic faster in the 19th century. So something else is going on to make it faster, and we don't know what it is yet. But one of the things that we do know is that it has a big effect. And if we look at, for instance, Siberia, and we look on the right-hand side here, we see from the year 2000 that the Siberian Arctic has warmed by about up to 6 degrees, while the rest of the planet has warmed by less than 2 degrees. And the result is, just incredibly, the Arctic has caught fire. This is the tundra in Siberia, broke out into a brush fire a couple of years ago, and it ended up being the biggest fire in the world because the Russians didn't do anything about putting it out. There was nobody living up there, so they thought, well, we'll just leave it. And it died down during the winter, but stayed smouldering, came back up again the next year, and is still burning. So this is the amount of carbon dioxide. It's also the longest lived and biggest brush fire in the world. And it's because Siberia, that you think is cold and wet, is getting hotter and drier. So here's some, and of course we have brush fires in a lot of other places. This was one I passed by when I was driving through California, and I saw this fire. I thought it was an apartment building on fire, but in fact it was a canyon coming down into the town of Pasadena, where all the underbrush had caught fire, and in fact for about 40, the freeway was closed and you couldn't get about at all. We look at what's happened to the ice, and these two pictures show the area of the ice in the summer. I was showing that the area of ice in the summer on the left in 2012, that was the biggest retreat so far, and the area in the summer in 2020. Now, the area is about the same. The sea ice hasn't retreated much more in the last 8 years, but what's changed is the colours, and the colours show the age of the ice and the thickness. So the left hand shows what was called multi-year ice. That was really thick, heavy ice. And the right-hand side is first-year ice we get today. So we've got the same area of ice. This is the old ice I used to know in the 70s. But if you look there, go there today, have that same area, except the ice is very, very thin, thin enough to fall through. So the ice really is disappearing, but initially you don't think it is, because there's still roughly the same area there. It's just that the ice is very much thinner than it used to be. And that means there are a lot of things we can't do anymore in the Arctic. We can't do what we used to do, which was set up ice camps on the ice for several months at the time and study the ice conditions, because there isn't the ice cracks up in the winter even, and you can't land an aircraft on it anymore. These ice camps, if you want to study the ice, you have to freeze a ship into it. If you want to see how the ice has changed, you have to go underneath the ice in a submarine, because there isn't any method of measuring the thickness from satellite. We did, I've done several trips in submarines where you come up through the ice. This is just to show you what it's like to come up through the ice. But this is what it's like to be on a submarine, which is that it's not very comfortable. You sleep in with the torpedoes, and but we are able to measure how thick the ice is. This is a record of ice thickness, where you have a lot of very thick ice and thin ice present together. The thick ice is called ridges. But when you do this, and the Americans have it as well as the British, you find wherever you go in the Arctic, there's only about half the area of ice as there used to be. The blue is the area in the 50s and 60s. The green is the area in the 80s and 90s. So the ice is disappearing from the whole Arctic, both in thickness and in area. So what are the consequences of this? Well, there's a lot of changes that this rapid disappearance of ice is doing to the world. First of all, it's making the ocean more acidic. As the more carbon dioxide there is able to dissolve in the sea instead of being held back by the ice, the more acidic the ocean gets. And this shows the pH, which is the measure of the acidity. And the trouble is that the sea of the ocean is a measure of how good it is at dissolving carbon. So when carbon dioxide dissolves in the ocean, it's in the form often of shells, tiny shells, which are called foraminifera. That's little tiny shells about this big. And when the animal dies, they sink to the seabed and it's lost to the world. So it's a way of getting rid of carbon dioxide. But today, those shells redissolve in the water because of the fact that the water's acidic. And so we're not losing the carbon dioxide anymore. That's one thing that makes the carbon dioxide level worse. The next thing, which is a real threat, is are we going to be done in by first? And this is the fact that about a third of the Arctic Ocean, that's the light blue part, is very low water, only about 50 to 100 meters deep. And underneath it, there's a very thick layer of sediment, which is made up of methane, which is forming a compound with water, and it's called methane hydrate. So you go down and look under the water, you'll see thousands of meters of methane hydrate at the bottom of the sea. Now the trouble is that's fine so long as the Arctic Ocean is covered with ice, because then in the summer it stays frozen and nothing happens. But today the Arctic Ocean, the ice is melting in the summer, and so all of this layer of methane hydrate is being released and is coming up to the surface. This is what the stuff looks like if you dredge it up. It looks like ice, but in fact, if you strike a match, this stuff will burn. Here it is burning, coming as it comes out of the surface of the water. And here we have some pictures taken from a sonar system looking at plumes of this methane coming up from the seabed and coming right up to the surface and being released into the air. So one of the big factors increasing the amount of methane in the atmosphere is methane being released from this deep water or this shallow water in the Arctic Ocean. And that is a bigger methane level, and methane is a really powerful greenhouse gas. So this is increasing the greenhouse effect. Here we see some pictures taken by some Russian colleagues of the methane bubbles coming up to the surface, being stuck against some ice, and here they are. Well, anyway, methane has risen in. We thought that it was staying put, but on the left we see carbon dioxide rising fast, and methane stopped rising and then suddenly took off again. So methane is now rising faster than carbon dioxide. And another place where we're getting methane is from permafrost. Brown area here is the permafrost, which is a solid material of where ice has frozen to give what seems like solid rock, and people have built houses on permafrost. It's the Russians had towns built on permafrost, but that permafrost is warming, and as it warms, it starts to melt, and various things have happened. For instance, here we see permafrost which has collapsed and moved out to sea on the Arctic coast. So as we warm the atmosphere, the permafrost melts and starts to decompose. It's because permafrost has got vegetation in it. It's like frozen material you put in, you're free, and you pull it out after a year and wonders what happens to it. But this is this melting permafrost, and here's some on the coastline of Alaska, is as it melts, the ice turns into water. It's causing an increase in the rate of sea level rise. It's causing villages and towns to collapse. This is a typical house in Alaska, which was built on pilings of permafrost. That's gone. So this is a real threat, that the methane from permafrost will add to the methane from the Arctic seabed and cause the climate to warm faster. I'll mention a few other things. One is that people who are keen on veganism will say that a big contribution to global warming actually comes from eating meat. Big cows especially, but also pigs, emit methane from their stomachs when they're digesting. And this is a big contribution to global warming, a bigger contribution than people imagine. People thought it was a kind of joke, but perhaps it's more like 40 or 50% of global warming seems to be associated with eating meat. Another one is that we're going to get increased rate of sea level rise, because the island of Greenland, which is covered with a very thick layer of permanent ice, that ice itself is melting. I just show a few pictures because I was standing on the ice sheet in Greenland on August the 1st of 2019, which was the day on which we had more ice melt than any in history. There was 12.5 billion tons of ice melted off the Greenland ice sheet that day. And of course, it flows down in the waterfall and ends up in the ocean, causing sea level rise. So here we see that happening, and it's speeded up by the fact that the ice is dirty. It's called black ice because the ice melts and the water flows out to sea, but it leaves behind the dust and dirt that's accumulated over the years, and that dust and dirt is black, and it melts, therefore, melts faster, melts the ice faster. So black ice is a big speeder up of the Greenland ice sheet melt. Here we see black ice with the cleaner ice underneath and a huge mass of water melted. We had, just to say, we had a big study there that was done in relation to a racing project done for electric cars. And so the car rally drivers helped to take up for us. And some of them are quite well-known people. This is Jenson Button, who was a Grand Prix champion, switched to racing electric cars because they're better for the environment. So we see the sea level rising, and I won't go into this because we're getting a bit too fast, slow. But I'll just end with one of the other things that we've seen happening in the last few years, which is called extreme weather events. And getting those here in Europe, we're getting them in America, sudden outbreaks of really hot weather, or even hotter than hot weather, or very, very cold weather. And the reason for that is, again, the Arctic, because the Arctic faster than anywhere else, and the air mass over the Arctic, the polar air mass over here, is getting warmer, while the tropical air mass is not getting warmer so fast. The difference in temperature is going down, and that means that what drives a very strong wind around the whole world, which is called the jet stream, the force driving that wind is weaker, because you have in the polar regions and not so hot air in the tropics. So that weaker jet stream breaks up into these meanders, and the meanders give you places where there's warm air going in Arctic where it shouldn't be, and there's hot air coming down to the tropical regions where it shouldn't be. Either way, you get you get weather where it shouldn't be. The jet stream is no longer a straight line. And the trouble is, the place that happens, where all these events occur, is just where there's that brown line in the Northern Hemisphere, which is where all the crops are grown. That's North America, Europe, and the Ukraine. That's suffering from weather events. Also, the climate itself is warming, which is reducing the yield of all of the main eat. So there's going to be a really big crunch coming up for food. And we already know that because the UN produced a index in the year 2000. And this is how food prices on average around the world have gone up in the last 20 years. and they more than doubled. And this is extremely nasty if you're living in a third world city where you can't grow food, you have to buy it. And that's increasing the difficulty of surviving in the third world. And it's going to get, these are UN predictions of population by the end of the century in different regions of the world. And one that's going to increase fastest is Africa. And it's expected to quadruple in numbers by the end of the century. How do we feed 4 times as many people as we feed now in Africa when the growth of crops is being hit by these weather effects which are related to ice? So there we are. And I guess I just wanted to show what do we do. And everybody says, the UN says, what we have to do is to cut our emissions, and that will save us. The trouble is, carbon dioxide stays in the atmosphere for thousands of years. If you reduce the amount of carbon dioxide you reduce your car usage and so on, it will slow the rate of warming down, but it won't ever bring it down to less than 0. It will cool the climate. So the only way to cool the climate is to actually take carbon dioxide out of the atmosphere. This is what a lot of scientists are trying to do now, including some scientists at my institute. So the joy that the UN had when they came to the Paris Climate Agreement was misplaced. They were saying, oh, we've solved the problem because everybody's going to reduce their carbon emissions. But firstly, nobody did. And secondly, even if they did, it wouldn't be enough. You've got to actually get rid of carbon dioxide. So the various ways that are being tried, one is to brighten up clouds by pumping water, finely divided water particles into it. That was invented by a Scottish scientist. Another one is to waste, agricultural waste, to produce a kind of a charcoal called biochar. And that's stuff. And another way, but the way that most people are trying to work towards, is to actually take the carbon dioxide out of the atmosphere by passing it through a scrubber and then getting rid of it somewhere, putting it underground. And the best place that's doing that at the moment is a company established in California called Blue Planet, which turns the carbon dioxide into limestone. And then you can turn the limestone into concrete. And here is carbon negative concrete. And that can be used for any purpose. This is roofing an airport terminal. It's getting rid of the carbon dioxide by turning it into a useful product, not by trying to put it away in a cave somewhere. This way is to put it away in a cave, and there's a company in Iceland which does that because they've got some big volcanic caves. So people are working on this, and the group at Polytechnic in Torino has been working on taking carbon out of the atmosphere, and the problem was that they started to do it in Puglia and they had to stop because of COVID. So there's now going again with this Blue Planet people. So that's where we're now. We should be focusing all of our attention on carbon dioxide out of the atmosphere. That should be man's biggest effort, because it's no good just reducing our emissions. We've got to take the stuff out of there. And that message hasn't really caught on yet, but I hope it will. And in the meantime, we're getting a lot of support from young people. And if you want to read about this, then it's in translation by Pia is sitting outside called Addio, Ghiacci. And there's a film. This is, if you like, Leonardo DiCaprio. He made a film about climate change, of which the cover advertisement is somebody stabbing a lake in Siberia, and the methane's coming up and setting him.
And it's available on Netflix?
Yes, it's available on Netflix. It's available. There's pirated editions you can get at on Wi-Fi.
Thank you very much. Let's give Professor Wadhams a big round of applause. We have, Professor Wadhams, we have more or less 15 to close this event, so we go straight to the questions from the audience. If you can, there's a question over here, please.
I'm not permitted to actually touch it. Great presentation. Thank you very much. A bit of a technical one to start. The methane hydrate. It's just one of the few bits of that I thought I'd heard in the last few years. The bubbles are likely to be very, very small, and a certain amount of the methane will be digested by bacteria going up. Has there been, and the number I heard was it was about, they were hoping it would be about 80%. We got any better guess than 80%? But I'm guessing it's not going to probably go up.
Yes, unfortunately, I think the amount that gets to the surface depends on the water depth, because as the methane rises, it does dissolve in the water. Looking at deep, something like more than 400 or 500 meters, all the methane coming up from that would dissolve before it reaches the surface. But if you're looking at only 50 to 100 meters, nearly all of the methane actually comes out. So it's the shallow water methane that's the real threat.
Any other questions from the audience? I have one question from you, because we met earlier today, and you told me that you attended the lecture delivered by Professor Macmillan last night, and you told me that you had a kind of a eureka moment listening to his lecture about organocatalysis. How could he, according to you, how could it help your cause?
It's purely hypothetical, but he was showing in his wonderful talk that how many things you can do with catalysis, how many new species you can produce, and he started to think about carbon dioxide, because we want that, and he thought about, could we turn it into methanol? And we wouldn't then want to burn it, you would put it somewhere. But he was thinking about, could there be a catalytical method to get rid of carbon dioxide, turn it into methanol? So that's, I hope he's gone away to think about that. He might have forgotten it, but I think it's a great idea, because the big problem with getting rid of carbon dioxide is cost, energy cost. Because you're trying to sell dioxide from the rest of the atmosphere, and that takes energy, and so you don't want to use a huge amount to get rid of carbon dioxide, because you want your energy anyway to be coming from renewable sources. Otherwise it's pointless to burn coal or oil in order to get rid of carbon dioxide, because you're producing it. So you want a method that doesn't consume fossil fuels, and so catalysis might be the answer there. So I hope that with more work that might lead to a breakthrough, a way forward anyway.
So we need more research on the issue, on the catalysis part. But you showed us a few experiments taking place in Iceland and California. I believe that there's an issue with costs, as you mentioned. Are we still on an experimental phase? are we going practical phase?
Well, it's still mainly experimental. The company that's done most, well, this goes back a bit. The company that's done a lot is a company in British Columbia that uses uses hydroelectric power, and this is a Climax, which is a Swiss company, but it operates mainly in Iceland and uses geothermal heat, and then the carbon dioxide that is separated is pumped into hollow caves when it then forms a complex with rock. So there's only a few places where you can free energy and a place to put your carbon dioxide. And that's unfortunate because we've got to do this worldwide. There's 40 billion tons of oxide put into the atmosphere every year, making the planet less and less habitable. So we need a way to take 40 billion tons out of the atmosphere. And all these experiments that people are doing are wonderful, but they're not going to get 40 billion tons. They might get a few thousand tons. So we need everything to be scaled up enormously, and then to take it so seriously that it's the most serious thing that the human race does. Otherwise, we've had it.
I have a double question, actually, because when we last met 2.5 years ago, it was prior the pandemic, and the world was very involved in terms of environmental activism. You were showing Greta Thunberg. There were talks, like people were saying that she was deserving the Nobel Peace Prize. There was a huge attention, like on a global scale, on what young people and Greta Thunberg in particular was doing in terms of the environment. Then the pandemic came, then the Russian-Ukraine war came, so the environment got in the back of our minds. So what can we do in order to bring the issue at the forefront of the discussion? And secondly, I know that like it looks as if this issue is bigger than our what we can do as individuals, but can we do anything to face the issue and to give a contribution, even if contribution?
Well, I guess the best thing that can be done, first of all, is to stop the war in Ukraine. Not only is it a terrible thing, but it's diverting everybody's attention from climate change. But in the end, climate change will be far more terrible for the world than any war. So it's to get peace and get basically try and persuade Putin that he's bonkers. But the other thing would be to bring more attention to global change is, again, involve young people, because that's where the future lies, indeed, doing something about this. And so bring back the sort of spirit of Greta Thunberg. And for individuals, when people ask, well, what can... there's many things, but two simple things, which are very, very simple. One is to stop eating meat. I'm not a vegan fanatic myself, because I like eating meat and fish. But the evidence is absolutely strong that a large fraction of global warming, surprisingly, is due to meat eating. It's production of use of land to produce meat for, and the amount of meat being produced is going up all the time, because as nations like China get more India, they're able to eat better. And the first thing that anybody thinks about when they can eat better is so instead of eating less meat, which is what we need, the world is eating more meat, and that's using more and more of the productive land in the world for livestock, and there's less and less available for growth of crops. So eating less meat would be a good idea. You don't have to give it up, but at least eat less. And then another one would be don't drive an SUV, because if you need to drive around, which most people do, you don't have to drive a tank around to get from A to B, especially in a civilized city in Europe where you have decent roads. So SUVs, I think, are something that we ought to frown and stop using if we can, because their fuel consumption is about 50% higher than other cars.
The questions from the audience. What can we expect in the next 5 years?
Well, within 5 years, I think the ice will disappear from the Arctic in summer, and I think within 5 years, all the things we're seeing will get worse rapidly. And what worries me is that we saw these trends like carbon dioxide rising. Everything was getting readily, but this year, and not only this year, but these last month or two, things seem to have taken a dive like off a cliff, as it's started to warm up and change much more rapidly, much more frequent. Weather events, increased heat to the point where it's killing people. It's really a disastrous speeding up, and in the next few years that will get, unless we can do something like get rid of CO2 from the atmosphere, then that will get worse. It will get accelerating warming, accelerating effects that we don't like, will be happening over the next few years. It won't get better, it will get worse.
Thank you, Professor Wadhams. We were talking about the contribution that we can make as individuals, and we have tonight Maria Pia Casalini. I would like her to come and join us on stage. Maria Pia Casalini. No, please sit. She can sit here. Maria Pia Casalini is Peter Wadhams' wife, and also the translator of the book we mentioned a few minutes ago, Farewell to Ice. But mostly, she is the chairwoman of an association, Polar Educators, that is actively contributing to spreading this information. So we decided to invite her on stage in order to tell us a little bit more about this institution, this organization doing, and how we can support your activity. So thank you for joining us today.
Thank you for giving me this opportunity. It's all great. Antonio is a great supporter of Polar Educators International. It always gives me a little bit of time to talk about it. This is a network that started in about 2012, and it was an offshoot from the International Polar Year, where teachers and educators got together at a conference in Montreal. So Polar Educators International started then. It's only a network that works online. And in fact, I'm giving here all the information, and anybody can join, anybody who's interested in spreading the word, because anybody can be a polar educator. This is what you're saying. You don't need to be a teacher in a class. Good if you can be one, but it could be anything or anybody. So look at the website, join. Everything is free, volunteers, and it's a group that has over 1,000 people all over the world. And we are doing quite a lot of work. We are growing quite a lot, actually, because we are participating with big associations like the Scientific Scientific Committee on Antarctic Research, APEX, which is the Association of Polar Early Career Scientists, and IASC, International Arctic Science Committee. And
you mentioned that you're also working on a book.
Absolutely. In fact, I put it here as it was a book that came out from that Montreal conference in 2010. We call it the Polar Resource Book. And it was very useful because it was scientists and educators. And the educators need the scientists to give them content. But a lot of the time, the scientists need the educators to help them to explain things in a more accessible way. So that's the point of Polar Educators. Now, we had the permission from the publisher to actually use the old book, which is now available free. So if you go to the website, polareducator.org, you'll find that you can download the book. You can download any chapter you like, you can look at it. Part is the one that is suffering a bit more because it was written in 2010. That's why we want to do an update. The part that can be used, young people, for teachers, for initiatives to make the polar regions and the polar education better known, that's easier because those things don't really change. So we are now hoping, in fact, I'm coordinator with those associations that I mentioned for a new edition of the book. And it's not an easy job because we need quite a large input of money. And that is not easily available. So we are just starting now some serious fundraising. We start the new year of Polar Educators. We do in June a new council, new people. And if I can share with you, as of last Sunday, I was elected the president for this coming year, 22-23. So. So it's a great opportunity. We are not a big number of people, but the council a lot, and we welcome scientists, we welcome educators, we welcome anybody. So I'm really grateful to Antonio to give me this opportunity to share this Polar Educators International with you. And just look at the website or follow us on Facebook or all the other things. Again, we want... no, oh, sorry. Okay. We had to learn. You know, we got new people of council that we always say we want somebody who's very good with social media. So hopefully somebody will come up to help us. And at any time, you know, with Gmail, you can send it to me or to anybody. And thank you for your attention.
Thank you. So since the room tonight is students coming from all over Italy, and they're very well involved in terms of environmental sciences, we all invite you to go and check out www.polareducator.org and get more information on this activity and how you get actively involved in contributing to this cause. So I would like to thank Professor Peter Wadhams and Maria Pia Casalini for joining us tonight, and mostly for the most precious work in scientifically and in communicated such an important issue. Io vi ringrazio per aver trascorso questa serata con noi alla Green Week. Non si conclude qui, domani vi aspettiamo sempre qui al Centro Paganini alle ore 10 per gli ultimi appuntamenti della mattinata. Io vi ringrazio per aver passato con noi questa serata di giugno e ringraziamo Peter Wadhams e Maria Pia Casalini e grazie a tutti. Buona serata.